Hello friends, this is our day 39 for solving problem of the day from GFG. Let's look at today's problem. Given a binary search tree with unique node values and a target value, we have to find the node whose data is equal to target and return the sum of all descendant nodes data which are vertically below the target node. Okay, so this is uh, a little bit tricky problem. Let's see how to solve this. So first let's take this example. Okay, so here is our tree, right? 25, 20, 35, 15, 22, 30, 45, 32. So this is a binary search tree, right? So in binary search tree, the left values are small, the right values are big. Okay. So all the right values of 25 are bigger than 25. All the left node values of 25 is smaller than 25. See, and this property holds for every node. For 30, all the right node values will be greater than 30, and similarly for the left node values it will be smaller than 30. So what the question is basically saying is suppose you have given a target value which is 35 and this tree we have given two things. Okay, now see that if you concentrate on this 35, then below 35, okay, below 35 is the descendant part of 35. Okay, it's descendant, I think, descendant nodes data. Yeah. So below 35, the nodes which are at same level as 35. Now what is that level? Its meaning. So that we have to understand. And so below 35, uh, the nodes which is at the same level as 35, we will take all those nodes and sum up and give the sum. Okay, that is the thing we have to do. So let's see what is level. So suppose this is a tree. Okay, 10, 20, 30, then 40, then suppose this is 50, then okay, so it will not like this. Suppose this is what can I say, suppose it's 25, this is suppose 26, again suppose it is let's see, this was 29, this is suppose 26. Okay, no, it can yeah, 26. So let's focus on this tree. So if you think this tree like this, let me use line. If you see the tree like this, so if you see the tree like this, it means if you draw these lines in your mind, then all the nodes just before, suppose I am considering this line, all the nodes before this line and after this line, before this line and after the previous line will be considered as at same level. All the nodes before this line, after this line will be considered as the same level also. So 20, there is no node for 20. So 20 is the only one it's in its own level. So 25 26 are at the levels of 10. 29 is at the level of 30. Okay, so this is the thing you can say. Now suppose we have suppose 21 here. So 21 and 20 are at same level. Okay, this level is same level. So that is the thing. So if you given a tree like this, 10, 20, 30. So forget about the binary search tree. Just look as a tree only. Okay, don't need to bother about the tree when talking about the levels. 40, 50, 60, 70. So can you tell me that which nodes are at the level of which nodes have the same level as 10? Yeah, that is pretty simple, right? Just draw like this. Now here is a problem. How can you draw like this, right? So this is not possible to draw like this. So actually this is like what? This is like you can imagine this like 50 here and 60 also here. You can imagine also like this. Okay, that's the thing. So what I meant to say is 10, 50 and 60 are at same level. 30 is at same level with only one node. 70 is at same level with only one node. So the nodes having same level as 10 are 50 and 60. Okay, so that is the thing. So now how can we approach this? This is a diagrammatical thing, right? So how can we approach this in perspective of coding? So that's very easy. Okay, that's very easy and easier than this diagrammatical presentation actually. Okay, so what we're going to do, so don't think perspective of BST, just think this is a tree. Okay, and so 40, 50, 60, 70, 80, 90. I should draw this like this. So diagrammatically 20, 80 are at same level, 10, 50, 60 are at same level, 30 is alone, 30 is alone, 70 is alone, 90 is alone. Now see, if I assign here a number, suppose 0, and whenever I go left I assign a number to the left part by just uh, decrementing this number by 1. What I meant to say, if I go 20 from 10, I will assign -1 to 20. If I go 40 from 20, I will assign -1, -1, that is -2 to 40. Similarly, if I have 30, if I want to go 30 from 10, I will increment the number, this number, okay, only by 1. If I go from 30 to 70, I will increment 1, 2. From 70 to 90, it will be 3. So what it will do, it will actually play the role of the level. Okay, so see, if you have 0 here, you go by 1, that means actually you go right. Here is your same levels nodes, right? Here is your same level nodes. If you go right, then you are actually one ahead of your level. This is your level, you go one ahead of your level, that is right side. So if you come back one level, that is from 30, if you go left, then 1 will become 0, right? 1 minus 1 is 0. I am just incrementing the level x. So if there is a node with level x and I want to go in the left side, then these nodes will be assigned with the level x minus 1. And this, if I go from x to r node, if I go from this node to the right side node, the right side node's level will be x plus 1. So if you go 10 to 30, you will get 1. 30 will be assigned with 1. Now if you go left side from 30, so 1 will become 0 for 60. Now see, that's the thing. So you go ahead 1, you go ahead by 1, and you come back by 1. So you are reaching at the same level, right? Similarly here, from 10 you go left by 1, and you go ahead by 1, you will again come back to 0. See, 10 to 20 it is minus 1, 20 to 50 it will become minus 1 plus 0, so 50 will become 0. So 50, 60 are at same level, right? So we will check this level values with our level values. So if these level values are same, they are at same level. Okay, let's check out a small part. Let's check for this part. No, let's check for 10, 20, 30, 40, and 50, 60, 70. Let's check if 60 and 70 are at same level or not. Okay, so let's assign 0 to it. In code we are not going to assign 0. Okay, we will do that. We'll do that somehow. Let's suppose so I have assigning 0 to 10. So I will go from I will go to 20. My value will become minus 1 for 20. Here I will get 0. So 0 0 they are same level. Here I will get a 1 because that is the right node of 30. So 30 is having a value 0, and I go right side from 60. So 60 will have the value 0 plus 1. If I go left side, 40 will have the value 0 minus 1. That is minus 1 here. So for 50 it will be 0. For 70 it will be 1. So they have the same values, so they are at same level, right? And diagrammatically also it is true. That's the thing of level. Okay. Now, yeah. Now that is the first part. You have to check the levels. Now there is a second part also. Okay. So we have given this target value 35. So we will what we will do? We will just traverse. Okay, traverse like this. You. We will traverse like this, and while traverse like this, what we are gonna do is I'm traversing. Now here I got a 35. Okay, here I got a 35. So whenever I will get a 35, I should have a suppose a flag. I should have a flag which is initially false, suppose. So whenever I will got a target value as my node value, I will give it a true, and I have another universal flag which is also false here, and I will give it a true here. This flag, universal flag, it will be updated by once only in my whole program. This can be changed anywhere based on some condition. This will be updated only one time. Okay, so this part, this flag is true means that in my tree I have this target value, whereas this part is showing that you got your target value. Your tree has your target value, that is a separate part, and you got your target part, that is another part. Okay, so now whenever you got your target value is 35, so you will go like this, but when coming you will go like this. From here you will go like this, but when coming you will start uh, summing up the values. As soon as you get your target value, you will go like this, but when coming from the root node, you will start summing up the values until you get the target value once again. So here I will get the target value once again, not here. Okay, this is in order. I will do the summing up thing in the post order. You will get to see in my code. So whenever I will go like this and I reach my target value again, then uh, uh, I will uh, change this value to false. Okay, I am returning from the root when the leaf node, right? I am returning from the leaf node after getting my target values. In this part, I don't have the target value. So from here, when I will return like this, I will do nothing. But when I will reach here and get the target value, my this flag will be true, right? So whenever I am coming in the post order, here as our target, as our flag is true, so we will sum up the values. Starting this, we will start to sum up the values like this until we reach the target value again. When we reach the target value again, we will change this true to false, because after then we are not going to add the values. Okay, that is what we have to return. In the problem, we have given a target value, so we have to sum up all its descendant values, right? Descendant node values. That means all these values we have to sum up. So for that we don't need to sum up these values. This is the ascendant value, you can say. So we don't need ascendant value, but the post order will go from here to here also. The post order will go the descendant as well as ascendant ones also, right? So we have to stop them to take the ascendant values. That's why we are changing this flag to false. So here it will get a false, so it will not sum up this value. Okay, and then I will return. Now there may be a case where I don't get any target value. So in that case, this universal false will be false. So if this is false, we will return -1. That is the question is saying, I think, to return -1. Okay, target value is not present, return -1. And if this is true, okay, then we will return the some result. Let's code. Then we will just try run the thing. So this is a pretty simple thing. We're gonna just create a new function for us where we will pass the root target, obviously, and the flag which is false. Yeah, a flag which is false, right? And the level. Okay, now here we should have this flag, universal flag, suppose universal flag which is false initially, and our level which is suppose 0 initially. Then we will start to create our function solution. This flag is for just taking the count, taking all the descendant nodes into our count. This flag is not the universal flag. Okay, and this is for our level. Our level is 0, suppose initially. What we are gonna do, we are gonna just call for left and right, nothing else. Go to the left and go to the right. And wherever I am going left, I will just decrement the value by 1. And wherever I am going right, I will increment the value by 1. Now here maybe so if we get the target value in our tree, get the target value, that is our root data is equal to target value. So why I am using data? So they have given the data here. Okay, they have given the data value by data keyword. So if my root data is equal to target, I will not only change the temporary flag but also the universal flag. Universal flag will be true, right? And I will set my level as I have achieved the target in my tree. So I need to find the descendant nodes whose level are same as the so that's thing I missed I think. So not only we don't need only we don't need the descendant node sum value. Okay, we need the sum value. We need the sum value of descendant nodes of this 35 together with the property that those nodes have the same level as 35. Okay, so for example 32 have the same level as 35 here, so we will take only 32 in our count. So our sum actually will be 32, which is actually my answer. So if you don't understand it, don't worry, we are gonna try run this. So our level will be same as target value. So why I am doing the level equal to target, oh sorry, not target, uh, level equal to, okay, so let me put this target level. Okay, this is my target level, this is my the level of my target value. Okay, so this is the thing, and if my root is null, just return 0. And here is the part in the post order where we will do our work. So if my target if my if my level is equal to target level and the flag is true, then we will add our sum by the root data and and do nothing, return the sum. So you have to keep here a sum also. Okay, and here if we so while coming back from the leaf node, so if we find our target value once again, that means our root dot data is our target value, so set the flag as false. Okay, so let me do these things here also, because this program is gonna run many times. Why I am writing these things twice, because when the program will run twice, these value may be changed to some other values. Okay, so as they are so it may be give some error, that is why. So I think I'm done. Let's compile this. Okay, we have false, we have error. Universal flag is false, universal flag is true. Converted to int. Okay, so okay, we will return. Okay, so one thing to notice, so if our universal flag is false, that means we didn't find our target value yet. So we'll return -1, otherwise I will return answer. Okay. We can't find the target value in our tree. So what will be the descendant node value having the same level and all, right? In that case we will return just -1, otherwise we are going to return answer. So it's running. Let's submit this. So it runs. That's cool. Now let's dry run this thing. Let me erase this things and take a screenshot. Let me take this example. Okay. So here we are starting from root. Okay. Our universal flag is false. Our flag is false. Our label is 0. Okay, so we don't have level, we have target level as 0. Target level is the level of our target value present in my tree. Okay, so starting from here, so left call, right call, that means it will go like this. It will go like this until this line, this condition is true. So here, sorry, here this condition is true. Root dot data is our target value. Okay, so now our flag will be true, universal flag will be true, target level will be the target level of 35, which is, I think it is 0, it is 1. So how it's calculated, this is 0 initially, it will be -1, then -2, then it will be from here to here again -1, then 0, it will go like this, -1 0 1. Yeah, so this is how it is calculated, from 0 to -1 to -2, then from -1 to 0. So for 20, left call, right call. So for left call it will be -2, right call it will be 0. Similarly for this node it will be left call which is -1, right call which is 1. So level is 1. So we'll update my level as 1 as we have found the target value. Then it will start again until one of these conditions are true. So it will start in post order manner, right? Because this code is written in the after the recursion calls. So after all the recursion calls, this code is written. So this is actually working in the post order. That means after here. So here level equal to, so here it is -1. This is not -1. This is 0. So this is 0. This is 1. So here we got our level. This node level is equal to true level. 1 equal to 1, right? And flag is also true. So we'll add this to our sum and it will go like this. Is this have the same level as our target level? No. We'll go like this, post order, right? This. Here we will also check. So no, level is not same. This has level 2. So here this condition is true. Our root data is again equal to target data. Previous time you are going as the pre-order. This code is written in the before the recursion call. So it is a pre-order. It will go like this. And after the recursion call it is written, so it will go like this. Okay. So here this is matched, so it will be false. So here if this node somehow had the same level as this, it will not be added to our sum because our flag is false here. Our flag become false here, right? And our flag has to be true to add the node value to our sum. So this will not work. So that is the logic. So then I will just return my sum. Okay, which is 32. So that is how our code is working. So I hope you understand the problem. If you have any doubt, you can say into the comment section. And if you understand the problem very well, then do like, share and subscribe. See you in the next video.